Hello guys and welcome back to the reaction zone. In today's lesson, we're going to balance the Redox solution on the board in basic medium using the ion electron method. So the first thing to do is to split this equation into two half equations. And that will be I2 plus OH minus is going to give IO3 minus plus H2O. And then we also have I2 to give I minus. Now, when you look at the second half equation, you'll discover that the oxidation number by iodine here is 0. The oxidation number by iodine here is minus 1. So, it means that there is a decrease in oxidation number by iodine as you're moving from left to the right hand side of this equation. So that means that this half equation is reduction, and this half equation here is oxidation. The next thing to do is to balance atoms that are neither hydrogen nor oxygen. Iodine atoms here is 2, this is 1. So what we'll do at this point is to add 2 in front of IO3 minus. Iodine atoms here is 2, this is 1. So what you do here is to add 2 in front of I minus. Now that that is the case, we can now balance with respect to oxygen and hydrogen. So taking the oxidation half equation, we have I2 plus OH minus is going to give 2IO3 minus plus H2O. The number of oxygen atoms on the left hand side is 1. The number of oxygen atoms on the right hand side is 6 plus 1, 7. So which means that there is an excess of 6 oxygen atoms on this side. So what we do is to add 6 molecules of water to the right hand side. Why? Because the rule for balancing oxygen atoms in basic medium is that for each excess that a molecule of water is added to the side of the excess and 2 OH minus is added to the other side. So I'll simply add 6 here, and then that means that I will have 12 OH minus on this side, and then I add 12 here. So when you look at this, the number of oxygen atoms on this side is 6 plus 6, 12, and here it is 12. The number of hydrogen atoms here is 12, and this is also 12. So the next thing to do is to balance the charges. For the left hand side, minus 1 times 12 is minus 12, minus 1 times 2 is minus 2. So, what do we do to minus 2 to make it become equal to minus 12? Is to add 10 electrons, so plus 10E minus. And this is equation 1. For the second one, we have I2 give us 2I minus. There are no oxygen atoms in this second half equation, so we go straight to the balancing of the charges. On the left hand side, it is 0. On the right hand side, it's minus 1 times 2. Which is minus 2. So what do we do to 0 to become equal to minus 2 is just to add 2 electrons to this side. Because when we do this becomes minus 1 times 2 minus 2, and 0 minus 2 is minus 2. So this is equation 2. Now the next thing to do is to ensure that the electrons in both equations are the same. In equation 1, we have 10 electrons. In equation 2, we have 2 electrons. 2 is a factor of 10. So, which means that if I multiply equation 2 by 5, the number of electrons here will become equal to the number of electrons in equation 1. So, equation 2 multiplied by 5 is going to give me 5I2 plus 10E minus to give us 10 I minus. This is our equation 2. So I can write my equation 1 in that is, which is I2 plus 12OH minus. It will give me 2iO3 minus plus 6H2O plus 10E minus. And this is my equation 1. So what I have to do at this point is to add both equations together to get my final answer. 5i2 plus 1i2 will give me 6i2. And then, this will cancel out, plus 12OH minus, and put the arrow sign. Here you have 10I minus plus 2iO3 minus plus 6H2O. Now if you look at the 5 chemical species in this thing that is the final answer, if you look at their molar coefficients, you discover that 2 is common. So you can divide across by 2 to get my final answer. When I do, this balanced equation here will become 3i2 plus 6OH minus 10 divided by 2 is 5i minus plus iO3 minus plus 3H2O. So when you divide across by 2, since 2 is common to their molar coefficients, you get that, and that's the final answer. So let us check if this answer of ours is correct. So we'll list the atoms on both sides of the balanced redox equation. Iodine is here. Iodine, we have oxygen on both sides, we have hydrogen as well. So let us see. Iodine atoms here, 3 times 2, 6. Iodine atoms here, we have 5 here plus this one, that is 6. Then, oxygen atoms, 6. Oxygen atoms, 3 plus 3, that is 6. Hydrogen atoms, 6. Hydrogen atoms 3 times 2, that is 6. So the next thing is to check if the charges are equal. Charges, minus 1 times 6 is minus 6. Minus 1 times 5 here is minus 5. Minus 1 times 1 is minus 1. So minus 5 minus 1 is minus 6. So we can see that the atoms on both sides of the balanced equation are equal, as well as the charges. That tells us that this answer is correct. Thank you very much for viewing, and see you some other time.